Do you know you can generate the interactive map layout in Python using GeoPandas library? In this particular video, I'm going to walk you through this step of generating this kind of beautiful maps in Python. So if you don't know how to generate these maps, make sure you watch the video till the end. Let's get started. In order to generate the beautiful maps, first of all, you need to import the dataset. Don't worry, I'll provide the dataset in the video description, and you just need to upload it in the Google Colab platform. And after that, you need to install the GeoPandas library. So I think I already installed this package, so it says requirement already satisfied. But if you haven't, then make sure to uh, simply install it. And after that, the next step is to import the GeoPandas library as gpd, and also import matplotlib.pyplot and those are the two things for now we need. And after that, simply you can try your GeoPandas data frame by gdp dot read file, which will read the file using whatever path you provide. It can directly read from cloud, it can directly read the shapefile, sorry, gpd.read file. And after that, if you want to see the dataset, then you can use the head method to visualize only the 5 data point. For now, I'm using the Nepal district dataset as it has the attribute of object ID, district, province, and the sum length, sum area is I feel like these are the like perimeter and area. I think both are same. Maybe these are the like area of the particular polygon in meters, and also the geometry. We get everything. Normal way to like visualize this data set is to using plot function. This is the simplest way of like plotting your data and visualizing in GeoPandas. As you can see, this is the shape of Nepal and it has 77 districts. So these districts are like represented by these border lines. And also for the like plotting using column, which is the like choropleth map, maybe based on the shape area. So you just copy this and paste it over here. So this is the column name. So this is the like choropleth map based on the shape area. So basically I feel like the purple color has the lowest area, and then the yellow color has the highest shape area value. So basically you can do the same thing with the your population data set as well. Just you need to replace this column by the your population data set or whatever you have the numeric value. And the if you want to like explore so gdf plot, if you want to explore the number of like keywords, which I mean the parameters, then you can of course see that. Of course, in the kind this is the our map, so we are not going to like plot this kind of like plots, so we don't need to represent the kind. And also you can use the cmap, which is the like representation of like changing of color of the map. So basically if I copy this and then paste it here, and then I change cmap to like RDYLBU, then my color map will be different. So this is the different color map. If you are wondering what are the like all the available cmap values, then you can search for cmap matplotlib, and then you will end up in this website. So here you can see all the available color ramp with their name and then the actual color. So for example, if you want like the blue color, then you can use the winter as a color name, and then your like the color variable will be look like this. And for example, for the HSV, if I provide the red color represent the lowest value, and then again I think it's the pink color for the highest value. For example, HSB, and yeah, here we go. Okay, so yeah, those are the few important parameter. Also you can say that whether you need legend or not, and if you say legend equal to true, then your legend will be plotted in the side. So this is the actual legend. So based on shape area, maybe you can use some area, and then you will get the different legend. So yeah, so based on the like categorical value, you will get the different legend. And also there are few other parameter as well. You can like simply explore, you can explore these things, but the another major parameter is vmin and vmax. So you can cut up the minimum and maximum value, and then force your legend to like plot it within that limit. For example, for the vmin, let's say I provide 1000, and vmax value I think it's up to 7000, maybe I provide 6000, and above 6000 it will plot the same like legend. Sorry, something went wrong. Minimum value must be less than or equal to maximum value. Oh, it's 600. It should be 6000, not 600. That's why. Okay, so this is the legend. So any value below 1000 will be represented as red color, and then sorry, the legend is a little bit confusing. Maybe you can use the different cmap value, cmap from here, because it has both in both end. It has like red value, red color. Maybe I can use OCEAN, ocean. Okay. Oh, yeah, it's like the white color represent the maximum value. That's why some of the map really went off. And then also you can provide the like edge color. I think there is a parameter called edge color. Mhm. I don't see the edge color. Oh, here it is in the style keywords, right? So if you provide the edge color, then your map would not be chunk, BLSCK, black. So yeah, you will get the like black boundary of the map, so that uh, it's white, but these are like two districts of Nepal, right? So yeah, and then other things, few other things I think that might be important will be I think that's the let me see, it's legend keyword. So sorry, legend keyword, and then you can provide the label to your legend. Label will be like some area. Again, invalid. Okay, sorry, I forgot the comma over here. So yeah, so here it is, some area, right? Similarly, if you have the population dataset or any other categorical dataset, you can provide the legend label as well. All right, so those are the like basic things with GeoPandas plot. But of course, we if we need to like tackle with the axis label and then the titles, then we might need the help of Matplotlib. So for the in order to use the Matplotlib, first of all you need to say figure in axis equal to plt dot subplots, and then you need to provide how many axes, how many rows, how many columns you want. Since this is only one map, so I'm providing 1 and 1. And fig size, and fixed size is totally optional, so you can provide for example I'll provide 10 comma 8. And then in the above map, so simply you can simply copy it and then paste it here, but here you can provide another parameter is ax will be your Matplotlib axis. That's how you can interact with the Matplotlib features. So now you can set the title of this map to like Nepal, and it's the some area. Maybe I can only say area, and then similarly set x label to x is longitude, and then set y label to latitude. And if you hit run, then you will see these kind of like the title and then the x and y label. But if you don't want like this latitude and of course this axis labels, you are only, if you are only interested in map, so you can say that first of all you don't need the legend, so just remove these, and then it's up to you whether you need a title or not. And then just comment out these things ax and set x ticks, and then you can provide empty, and then ax dot set y ticks, and then you can provide the empty list, so that you will get only the Nepal map. Sorry, I still need the as color. EDG is, sorry, it should not be in the axis. Instead you have to provide the as color over here. Okay, so if you hit run, so you will get only the map with its title, and it's up to you whether you want legend axis or not. So yeah, this is the like the basic map using Matplotlib and then the GeoPandas plot function. All right, so the now the other thing I would like to generate is the map based on the province boundary. That means there are 5 provinces in Nepal, so I want to generate the 7 provinces in Nepal. I want to generate those 7 maps using Python automatically. So in order to do that, so I first extract the provinces from my data frame. So it's GDF dot unique, and then if I provinces, print out provinces, so there are 7 provinces: Sudur Paschim 5, Gandaki 2, Bagmati 1, and Kadali. Sorry, this data is a little bit like old, that's why there are still numbers in some province, but I think these numbers already resolved and there is actual province name. So the thing is I'm simply getting this province feature from my geodata frame, and then I'm just extracting the unique values. That's why I said unique, and then there are 7 values. And for the like 7 maps, so I have to like is previously I have to take the help of my Matplotlib, and then this time fixed size will be 15 comma 10. It's up to you whatever size you want. And then I want to make this axis flat, which is I'll show you in a minute. So print axis and axis. Okay, the flatten means by default your axis will be like this, the two-dimensional matrix starting from here, but if you do the flatten, then your axis will be one-dimensional matrix. That's the meaning of flatten. And of course, as I said you previously, so as you can see here, there are like 7 provinces. We are trying to generate the figures of like 8 plots. So maybe I can remove the last axis. In order to remove that, so I can say axis, and then index start from 0. That's why it's the 7 is the last value, and then I just remove that. And if I hit enter, then you'll see that the last figure is already removed. And now I need to like iterate it based on like axis and then the province in zip, and then axis and then provinces. And if I print out AX and province, then you'll see like the actual axis and province. I think it should be axis. Okay, these are the like axis and these are the province name. And in this particular axis, we are going to draw the map for this particular province. So yeah, so now I need actually the province data frame. So GDF, and then my province should be equal to province. So I'm just extracting one province at a time, and after that I need to, maybe I can copy and paste the code from above. Okay, just simply copy this code and then paste it here, and little bit extract it here, and it should be like the gdf.plot, and then I'm plotting some area, and then axis is color, and this time I want different like the color RDYLGN, which means red to green color ramp, and then title will be the Nepal. Okay, this time it should be the province name, right? Province area, right? And after that I don't need these labels, and I'm also not interested in the axis. And if I hit run, so it should generate the 7 different provinces in 7 different axes. Sorry, I forgot to change here my data frame name. That's why you are seeing same map over and over again. So you need like df province.plot. All right, so these are the like 7 different province and 7 different maps based on your selected like province. So yeah, so still I'm wondering, like these box are not the same shape and it has inconsistency, due to which our map look a little bit ugly. So in order to fix this box issue, I have wrote some code. I'm going to copy and paste it over here, and then describe line by line. Okay, so first thing is like I'm importing the numpy, and then this is the same thing that we did before, and then I'm removing the last axis. And after that, maybe I need to change it to GDF, and GDF I'm selecting the province data frame, and based on that I'm calculating the total bounds. And my total bound, if you are wondering how it looks like, it's the like lower upper lower left upper left, those like the bounding box of like maximum and minimum value. Okay, if I print x1 y1 x2 y2, then you will see these are the like actual coordinates, right? Coordinates of that particular province, maximum and minimum coordinates. And after that, you need to like zoom the selected feature into the map. So for that, I select the maximum range, which is the numpy.array x2 minus x1 y2 minus y1 dot max. That means if map is elongated in the x-axis, then I'm just taking the maximum value of that, and then the medium point, the centroid of that maximum. And after that, I'm setting the x limit and y limit to like I first calculate the midpoint, based on x1 plus x2 by 2, and then I remove the maximum range in both x and y limit, and then this is for the buffer zone. So let me select these and then remove for now, yeah, and then show you how it look like. Control D, and simply remove it. And I'll talk in a minute about that 0.05 issue. And then for labeling the feature, I'm using like df province, and then I'm applying the function with I'm simply annotating that axis with the text is x.district, which is the name of the district, and then xy, my xy location will be the based on this x shape dot geometry, and then dot centroid. I'm writing that label in the centroid of that particular geometry, and then my label will be in center, and then this is the size of the like label, it's 7. And yeah, so after that I simply plot it using matplotlib axis. So axis dot set title, and then plot will be the column and axis and cmap. And as I discussed previously, I just remove the axis x ticks and y ticks, and this tight layout is for like removing the unnecessary white spaces in our map. And then I save the map as final map with the DPI is 500 and BB box 2 inch is tight layout. And let me simply run it again. And yeah, here is the map. The one issue with this map is like my upper or lower or like the left or right corner of geometry of the map is intersect with the axis. That's why in order to get the like the buffer zone, I simply remove the x limit to 0.05, and then similarly y limit to 0.05, and then here I added like the buffer zone 0.05. Okay, if I add that 0.05, and based on the coordinate system, you might also need to like add 1000 10,000 values based on your shape size, and your map will look like this. Since my coordinate system is WGS 84, that's why I only need to add or remove 0.05 value. And one thing you might be wondering that of course without the legend these map are like nothing. So you cannot say that what is this red color means and what is this green color means, right? So in order to like distinguish between these two, so you can simply like copy this code and then paste it over here. And as I showed you previously, so you can like assign the vmin and vmax value. And of course I know the vmin and approximate vmin and vmax value because I already plotted and tested that in here 1000 to 6000. But another way to like get this vmin and vmax is to like by simply using GeoDev dot and maybe the feature some area and then dot min, and this is the minimum value which is 113, and GeoDev some area dot max, and this is the maximum value. So I think I can say that I can fix my like the legend to minimum value is 500 and maximum is 8000. So that's the like I feel like that's the little bit nearer. So here vmin will be 500 and vmax will be 8000. Okay, so if I do so, my all the maps will be like plotted in the same legend, but my map of course it won't look that much nicer. But yeah, that's the way. So yeah, also if you need the legend, then maybe plot the legend somewhere else, and then later you can merge that legend in the map. But yeah, it's up to you. You can try like plotting legend over here as well. So whatever you like, you can try based on your own idea and your design. All right, so yeah, that's all about this video. I hope you enjoyed this video. If you enjoy it, hit the like button and subscribe to my channel. Thank you for watching.